Okay, really to dive into some quantum computing stuff today.
Sounds good.
So imagine a computer so powerful it could like design materials that can repair
Oh,
themselves.
wow.
Yeah, or revolutionize like how we grow food
Okay.
and even make like discovering new chemicals way safer and more efficient.
Yeah, that'd be huge.
That's the potential of quantum computing. And
It's closer than we think, right?
it's closer than you might think, that's right.
Yeah, it's really remarkable how fast this field is moving.
I know, right? We love to stay ahead of the curve here. So today, we're going to be digging into some big announcements from Microsoft
Okay.
about their quantum computing projects. They've revealed like a new type of quantum computer chip, a
Wow.
big partnership, and a breakthrough in making like super reliable qubits.
That's a lot to unpack.
It is a lot to unpack.
But it's really interesting that Microsoft isn't like putting all their eggs in one basket. They're
Yeah.
developing their own hardware.
Yeah.
They're working with other big players in the quantum space.
Right.
And tackling one of the most fundamental challenges, making sure those qubits are reliable enough to actually do the complex calculations.
Right. So let's break down these developments one by one.
Okay.
First step, the new chip, Microsoft's calling it Majorana 1.
Right.
What makes this chip so special?
Well, most quantum computers use qubits that are, to put it simply, very sensitive.
Okay.
They get easily disrupted by their environment, which leads to, errors.
Oh, so like they're really delicate.
Yeah, exactly.
Okay.
But this Majorana 1 chip
Uh-huh.
is built using a completely different type of qubit,
Okay.
a topological qubit.
Okay.
These are thought to be much more stable
Uh-huh.
because they're based on the way information is physically woven into their structure.
Oh, so it's like the information is protected by the chip's design itself.
Exactly. Think of it like this.
Okay.
Imagine trying to store information on a piece of string
Okay.
by tying knots in it.
Uh-huh.
If you bump the string, the knots are likely to stay put.
Right.
That's the basic idea behind topological qubits. They're more resistant to those bumps.
That's a great analogy.
Thanks.
And to build these topological qubits, Microsoft used a brand new material they call a topoconductor, right?
Yes. And the way they made this material is absolutely mind-blowing.
Okay, tell me more.
They used indium arsenide and aluminum, but get this.
Yeah.
They arranged those atoms one by one to create the topoconductor.
Wow.
We're talking about manipulating matter at the atomic level here.
That's insane. It sounds really complex.
It is. And to add another layer of complexity, the qubits themselves are based on these super exotic particles called majordas.
Okay.
These particles were purely theoretical for a really long time.
I see.
Scientists had never actually, created them before.
Interesting.
Microsoft published research in Nature,
Okay.
one of the most prestigious scientific journals, detailing exactly how they did it.
So they're creating particles that were once just mathematical equations and using them to build a computer chip. It feels like we're stepping into science fiction here.
It really does, and here's where things get even more interesting.
Okay.
Microsoft believes this technology could lead to quantum computers with 1 million qubits on a single chip.
Now, 1 million qubits, that might just sound like a big number.
Yeah?
But why is that significant?
So think of it like this. Each qubit is like a tiny bit of information the computer can work with.
Okay.
The more qubits you have, the more complex the problems you can tackle.
Right.
1 million qubits would give us the power to simulate and understand things that are simply impossible for today's computers.
Like what kinds of things?
We could design new drugs,
Wow.
create unbreakable encryption,
Okay.
and even unlock the secrets of the universe.
Wow, that's a lot.
It is.
So they've got this groundbreaking new chip.
Mm-hmm.
What's next on Microsoft's quantum agenda?
Well, they're not just focusing on building their own hardware.
Okay.
They've partnered with a company called Atom Computing
Okay.
to build what they claim will be the most powerful quantum computer to date.
Now, what's so special about atom computing?
Yeah, good question.
Are they using the same kind of topological qubits as Microsoft?
Not exactly. Atom computing specializes in something called neutral atom qubits.
Okay.
Think of it like this.
Okay.
These qubits are like tiny atoms trapped in a laser grid,
Okay.
and their quantum states are used to perform calculations.
I see.
This approach has some advantages when it comes to correcting errors, which, as we discussed, is one of the biggest challenges in quantum computing.
So each company is bringing its own unique expertise to the table?
Yeah.
It's like assembling a quantum dream team.
Right.
But why choose to work together? Couldn't they just compete?
Collaboration is actually really common in the world of quantum computing.
Oh, interesting.
It's a complex and rapidly evolving field,
Yeah.
and it makes sense to pool resources and knowledge.
Okay.
Plus, in this case, Microsoft's expertise in software and qubit virtualization could be the perfect complement to atom computing's hardware.
Speaking of qubit virtualization, you've mentioned that a couple of times now.
Yeah.
Can you break down what that means and why it's important?
Of course.
Thanks.
Pretty ingenious concept.
Okay.
Remember how we talked about how sensitive those qubits are?
Mm-hmm.
Well, qubit virtualization is a way to make them more robust
Okay.
by using software to essentially create virtual qubits that are less prone to errors.
Mm-hmm.
It's like creating a buffer between the delicate physical qubits and the calculations you're trying to run.
So it's like adding a layer of protection to those finicky qubits.
Exactly.
Okay, that sounds pretty crucial if you want to build a reliable quantum computer.
Absolutely. And that brings us to the third major development for Microsoft.
Okay.
They've made a huge breakthrough in the reliability of these virtual qubits.
Okay, let's dive into that.
All right, we've established that reliability is key in the quantum world.
Mm-hmm.
But what specifically has Microsoft achieved?
They've managed to create and entangle 12 highly reliable logical qubits using this improved qubit virtualization system.
12?
Yeah, 12.
Okay. To give you some context, most quantum computers today are working with just a handful of logical qubits. So 12 is a significant jump.
Hold on, you're throwing around a new term here, logical qubits.
Oh, right.
What are those, and how are they different from the physical qubits we've been talking about?
You're right. I should clarify that.
Okay.
A logical qubit is like a team of physical qubits working together.
Okay.
Imagine a bunch of those finicky physical qubits coming together
Right.
to form a more stable and reliable unit.
Got it.
That's essentially what a logical qubit is.
So it's like having a group of backup singers supporting the lead vocalist to create a more powerful and harmonious sound.
That's a great way to put it.
And Microsoft, working with another company called Quantinuum, has managed to create these super reliable logical qubits
Right.
and link them together through a process called entanglement.
Exactly.
Okay, I remember you mentioned entanglement earlier,
Uh-huh.
but refresh my memory on why it's so important in quantum computing.
Entanglement is one of the weirdest and most powerful phenomena in quantum mechanics.
Okay.
It's like two qubits becoming best friends.
All right.
They share the same fate, even if they're physically separated.
Okay.
This interconnectedness is what allows quantum computers to perform calculations in a way that's simply impossible for classical computers.
So it's like these entangled qubits have a secret language that allows them to communicate instantly no matter how far apart they are.
Exactly. And the fact that Microsoft has managed to entangle 12 of these highly reliable logical qubits is a huge deal.
Wow.
It suggests that they're making serious progress towards building a fault-tolerant quantum computer,
Okay.
which means a computer that can keep chugging along even if some of its qubits go haywire.
So to recap, Microsoft is making waves on multiple fronts.
Yes?
They've got this revolutionary new chip built with mind-boggling precision.
Right.
They're teaming up with another quantum powerhouse to create a potentially record-breaking machine.
Yes.
And they're making incredible strides in qubit reliability.
Very impressive.
It sounds like they're firing on all cylinders.
They definitely are. And it's not just about breaking records or achieving technological milestones.
Right.
These developments could have a profound impact on the world.
Yeah, how so?
Imagine a future where we can design new materials that can clean up pollution,
Wow.
develop personalized medicine that targets diseases at their root,
Okay.
and even create artificial intelligence that surpasses human capabilities.
It's almost hard to wrap your head around the possibilities, isn't it?
It really is, and that's just the tip of the iceberg.
Oh, wow. Okay.
We'll dive deeper into some of the potential applications of quantum computing in our next segment.
All right, listeners, if you're feeling even a little bit mind blown right now, you're not alone.
Yeah,
We've covered a lot of ground, but trust me, it gets even more fascinating from here.
it does.
Stick around for part 2, where we'll explore how these quantum breakthroughs could change the world as we know it.
It's going to be good.
See you there.
Looking forward to it. Yeah, it's truly remarkable how far we've come in a field that was once considered purely theoretical.
I know, right? It wasn't that long ago that quantum computers were just a concept in research papers, and now we're talking about building machines with millions of qubits. It's
Yeah.
incredible how quickly things are progressing.
Absolutely.
And it's not just Microsoft making waves. Other companies are also achieving amazing things with different types of qubits.
Right. Different approaches have different strengths for sure.
Right. Speaking of different approaches, I'm curious about Microsoft's decision to go all in on these topological qubits.
Mm-hmm.
It seems like a pretty bold move considering they're still so difficult to create and control.
It is a bold move, but potentially a very rewarding one.
Okay.
Remember how we talked about the sensitivity of qubits and how easily they're disrupted by their environment?
Yeah.
Well, topological qubits are theoretically much more resistant to that kind of noise.
Okay.
That's because the information they hold is encoded in their physical structure, making them inherently more stable.
So it's like they have built-in protection against errors.
Exactly. Think of it this way.
Okay.
Imagine you're trying to write a message on a piece of paper,
Okay.
but the paper is super flimsy and tears easily.
Uh-huh.
Now imagine writing that same message on a sheet of metal.
Okay.
The metal is much more durable and less likely to be damaged, right?
Right.
That's the basic idea behind topological qubits. They're less susceptible to the tears and rips that cause errors in other types of qubits.
That makes sense. But if topological qubits are so great, why isn't everyone using them?
Well, as with most things in the quantum world, it's complicated.
Okay.
Creating and controlling these Majorana particles, which are the building blocks of topological qubits,
Right.
has been an enormous scientific and engineering challenge.
Yeah.
For decades, they were purely theoretical,
Right.
these mysterious particles that had never been observed in the real world.
Interesting.
Microsoft is really pushing the boundaries of physics here, trying to tame these exotic particles and harness their power for computation.
It sounds like they're pioneers venturing into uncharted
I
territory.
like that analogy.
And their recent breakthrough in creating and manipulating these Majanas shows they're making real progress. They've essentially proven that their approach,
Yeah,
while challenging, is possible.
exactly. They've taken a huge step towards proving that topological qubits are more than just a theoretical concept.
Right.
And now they're focused on scaling up,
Uh-huh.
trying to build systems with more and more of these robust qubits.
Speaking of scaling up, Microsoft has stated that a topological quantum computer could potentially control over 1 million physical qubits on a single chip.
Yeah, that's their goal.
What would that kind of computational power even look like?
It's hard to even imagine, but think of it this way.
Okay.
Imagine every computer on Earth working together on a single problem.
Wow.
1 million-qubit quantum computer could potentially dwarf that kind of computational power.
Okay.
And it's not just about speed.
Right.
It's about the ability to tackle problems that are fundamentally impossible for classical computers to solve.
It's mind-blowing to think about. It's like comparing a supercomputer to an abacus.
It really is a whole new level of computation.
We're talking about a whole new level of computation, but remember, they're not just aiming for a large number of qubits.
Right.
Topological qubits, if they live up to their potential, would also offer incredible reliability and stability,
Absolutely.
which would be game-changing for the entire field of quantum computing.
Couldn't agree more. It's not just about quantity, it's about quality.
Right.
A quantum computer with 1 million unreliable qubits wouldn't be nearly as useful as a computer with, say, 1,000 highly reliable qubits.
Makes sense.
That's why Microsoft's focus on topological qubits, despite the challenges, is so exciting. They're aiming for both a large number of qubits and incredibly high reliability.
Yeah.
It's a long-term strategy, but it could pay off in a big way.
It's fascinating to see how different companies are approaching the quantum computing race.
Yeah.
Some are focusing on different types of qubits, while others are exploring different ways to improve reliability and scalability.
It's a very diverse landscape.
It's like a giant scientific experiment with the potential to reshape the world.
That's a great way to put it.
But beyond the technical details of how these machines work, I think it's important to step back and consider the bigger picture.
Right.
If Microsoft, or any other company for that matter, succeeds in building a truly scalable and reliable quantum computer,
Yeah,
what could that mean for the world? What kind of impact could this technology have on our lives?
that's the million-dollar question, isn't it?
It is.
The potential applications of quantum computing are so vast and far-reaching that it's almost impossible to grasp the full scope of what might be possible.
It's like trying to imagine the internet before it existed.
Yeah.
We can speculate, but the reality is likely to be even more transformative than we can currently conceive.
Absolutely, we could see breakthroughs in medicine,
Mm-hmm.
material science,
Mm-hmm.
artificial intelligence,
Mm-hmm.
energy production, and countless other fields. It's really hard to overstate the potential impact of this technology.
It's both incredibly exciting and a little bit daunting, isn't it?
Yeah, I agree.
We're talking about potentially reshaping the world as we know it.
We are, and that's why it's so important to approach this technology with a sense of responsibility.
Okay.
Quantum computing has the potential to solve some of humanity's greatest challenges.
Mm-hmm.
But we also need to be mindful of the potential risks and ensure it's used for good.
That's a really important point. Like any powerful technology, quantum computing could be used for both positive and negative purposes. It's up to us as a society to ensure that it's developed and used ethically and responsibly.
I completely agree, and part of that responsibility is having open and honest conversations about the potential implications of this technology.
Yeah.
We need to engage the public policymakers and experts from various fields to ensure that we're steering quantum computing in a direction that benefits all of humanity.
Well said. It's a conversation that needs to happen now, not after these machines are already out in the world. We need to be proactive, not reactive.
Exactly. And that brings us to another crucial aspect of quantum computing that we haven't talked about yet, the development of quantum algorithms.
Ah, yes, the software side of things.
Right?
It's easy to get caught up in the hardware, the chips, the qubits, the lasers, but without the right software, those machines are essentially useless.
Exactly. A quantum computer without effective algorithms is like a race car without a driver.
Okay.
It has all this potential power, but it needs someone to tell it where to go and how to get there.
So what's the state of play in quantum algorithm development? Is it keeping pace with all the advances in hardware?
It's a rapidly evolving field, and there are brilliant minds working on developing algorithms that can harness the power of these machines.
Good.
But it's fair to say that algorithm development is still lagging behind hardware development. It's a bit like having a powerful engine but not knowing how to build a car around it.
So even if we manage to build these million-qubit quantum computers, we still need to figure out how to write the software that can make them sing.
Precisely, and that's going to require a lot of creativity.
Uh-huh.
Ingenuity and collaboration between computer scientists,
Okay.
mathematicians, physicists, and experts in various fields.
Mm-hmm.
We need people who can think in new ways, who can bridge the gap between the theoretical world of quantum mechanics and the practical applications of this technology.
This brings up another interesting point, which is the role of collaboration in quantum computing.
Right.
We've seen how Microsoft is partnering with other companies to advance their hardware,
Hmm.
but it sounds like collaboration is just as crucial on the software side.
Absolutely. Developing quantum algorithms is a highly specialized field, and no single company or research group has all the answers.
Okay.
We need to share knowledge, expertise, and resources to make real progress. Think of it like a giant puzzle.
Okay.
We need people from different disciplines with different perspectives to come together and put the pieces together.
And for you listening, this is an area where you can potentially get involved.
Yeah.
Even if you're not a quantum physicist or a computer scientist, there are online platforms and communities where you can learn about quantum algorithms and even contribute to their development.
That's right. There are open source initiatives and educational resources that are making quantum computing more accessible to a wider audience.
Right.
You don't need a PhD to start exploring this fascinating field.
It's a great reminder that the future of quantum computing is not just in the hands of big companies and research institutions. It's a collective effort, and everyone has a role to play.
I couldn't agree more. It's a field that's brimming with opportunity and challenges, and it's going to take a diverse range of perspectives and skills to unlock its full potential.
So as we delve deeper into this quantum realm, it's becoming clear that the journey is just as exciting as the destination.
Mm-hmm.
The discoveries we're making along the way are already pushing the boundaries of our understanding of the universe and ourselves.
And the potential impact on society is immense. We're talking about a technology that could revolutionize healthcare, transform energy production, and even redefine the limits of human knowledge.
It's almost overwhelming to think about all the possibilities.
It is, but before we get too carried away, let's take a moment to recap what we've covered so far.
Okay, sounds good.
All right, let's see. We started by discussing Microsoft's ambitious approach to building quantum computers using topological qubits.
Mm-hmm.
We talked about the challenges and opportunities of scaling up these systems,
Right.
the importance of developing effective algorithms, and the crucial role of collaboration in this rapidly evolving field.
And for those of you who are just joining us, we're deep diving into the world of quantum computing, exploring the latest breakthroughs and what they could mean for the future.
We've only just scratched the surface, though.
Oh, really?
In our next segment, we'll dive into some specific applications of this technology, from drug discovery to materials science.
Okay.
Get ready for some truly mind-bending possibilities.
That's right. We're going to explore how quantum computers could revolutionize the way we develop new drugs-designed materials with incredible properties and even solve some of the world's most pressing problems. Stick around because it's about to get really interesting. So we talked about the hardware, the software, and the big picture stuff, but let's get practical.
Okay, sure.
What are some, real-world problems these quantum machines could actually help us solve?
The possibilities are pretty much endless.
I bet.
But let's start with an area that's close to everyone's hearts, healthcare.
Okay.
Imagine the world where we could develop new drugs and therapies super fast,
Mm-hmm.
targeting diseases with incredible precision.
Okay.
That's the promise of quantum computing in drug discovery.
Okay, how exactly could quantum computers, change the way we find new drugs?
Well, traditional drug discovery is kind of like trying to find a needle in a haystack.
Okay.
It's a slow, expensive process that involves testing tons of molecules to find potential candidates.
Right.
But quantum computers could, speed that up so much. They're really good at simulating molecular interactions, which is key for understanding how drugs work at the atomic level.
So instead of physically testing millions of compounds in a lab, we could simulate those interactions on a quantum computer
Yeah,
and quickly identify the most promising candidates.
exactly.
Okay.
Think of it like having a virtual lab where you can test countless possibilities without ever picking up a test tube.
Wow.
This could lead to new treatments for diseases that currently have no cure,
Like,
like Alzheimer's,
oh, wow.
Parkinson's, and many types of cancer.
That's incredible. It sounds like science fiction.
Yeah, it's pretty amazing, but it's not just about finding new drugs.
Right.
Could quantum computers also help us improve existing treatments?
Oh, that's interesting. Tell me more.
Absolutely.
Yeah.
They could help us make existing drugs more effective and reduce their side effects.
Oh, wow.
Imagine doctors using quantum computers to design personalized drug regimens for each patient.
That would be huge.
Yeah, tailored to their genetic makeup and medical history.
So it's like custom-made medicine?
Exactly.
That's pretty cool.
And it's not just healthcare that could benefit.
Oh, really? What else?
Quantum computers could revolutionize how we design new materials.
Interesting.
Imagine materials that can repair themselves like living tissue.
Okay.
Superconductors that transmit electricity with zero resistance at room temperature, or super-efficient solar panels.
Okay, you're getting me excited now. How could quantum computers help us create those materials?
Well, remember how we said quantum computers are great at simulating complex systems?
Yeah.
That applies to materials, too.
Okay.
These machines could help us understand how materials behave at the atomic level,
Okay.
allowing us to design materials with specific properties from scratch.
So instead of trial and error, we could use quantum computers to design your materials with exactly the properties we need.
Exactly.
Wow.
It would be like having a blueprint for building materials atom by atom,
Okay.
creating substances with properties we can only dream of today.
Yeah, that's pretty wild. It seems like quantum computers are perfect for simulating complex systems like molecules or atoms.
You're right. Classical computers struggle to simulate those accurately because they're based on classical physics, which doesn't really capture the quantum world.
Makes sense.
Quantum computers are designed to work in that quantum realm,
Right.
making them the perfect tool for these simulations.
Like using the right tool for the job.
Exactly.
So what other applications are there?
Well beyond drug discovery and materials science, there are so many more.
Okay.
We could see big advances in finance,
Okay.
where these machines could optimize investment strategies
Uh-huh.
and manage risk,
Okay.
revolutionize logistics and transportation,
Right.
like finding the most efficient routes for delivery trucks or airplanes.
Okay.
And they could even transform cryptography, creating like unbreakable codes to protect our data.
Wow. It sounds like almost every industry could be changed by quantum computing.
It really does.
We're talking about reshaping the world.
Yeah, and it's still early days, but the progress is incredible.
Mm,
We're seeing new breakthroughs all the time,
right.
and it's just a matter of time before these machines make a real difference in our lives.
Yeah. It's an exciting time to be alive, and for those listening, it's a great time to start learning about this tech and how it might change your life and career.
Absolutely.
The quantum revolution is coming, and those who are prepared will be the ones who shape it.
That's a great point. It's not just about understanding the tech, though.
Right. What else is there?
It's about thinking about its impact on society, both good and bad.
Right.
We need to make sure this powerful technology is used responsibly and ethically.
Couldn't agree more. So we've covered a lot today, from the technical details to the potential to solve big problems. What's your biggest takeaway?
I think the key message is quantum computing is not science fiction anymore.
Right.
It's a rapidly developing field that could revolutionize so many things.
Yeah.
It's time to start paying attention and talking about how we want this technology to shape our future.
Absolutely. And if you want to learn more, be sure to check out the show notes for links to all the articles we talked about and other resources.
There's a lot of great information out there.
We'll keep you updated on all the latest developments right here on the Deep Dive, so stay tuned.
Until next time, keep those quantum thoughts flowing, and remember, the future is what we make it.
Thanks for joining us.
It was a pleasure.